There's another force that reduces your car's acceleration as it rolls down the track, and that's called the force of wind resistance. Now boys, next time you're riding in a car, get permission from one of your parents to roll the window down and put your hand outside just a little bit. You'll really be able to feel the force of wind on your hand. Move your hand around and see if you can tell which shape offers the least amount of wind resistance. Do you want your hand spread open like this, against the wind, or do you want it closed together, pointed like an arrow? You want to design your Pinewood Derby car so that it doesn't have a lot of wind resistance. Take a look at these two cars. They both weigh exactly 5 ounces. Which of these two cars do you think has less wind resistance? What shape would you want your car to be to reduce the wind resistance? All right, I think we're pretty sure that the size and shape of a Pinewood Derby race car will affect its speed going down the track, but by how much? How important is this? You know, we might work really hard to make our cars small and smooth and tapered, and it might not even matter. To find out how important wind resistance is, we're going to have to do another experiment. This is going to be fun. I've taken our flat-looking blue car and set the weight to about 5 ounces. I've also taped a 3x5 index card on the back of it. We're going to run this car down the track, changing the size of the card between runs. For each card size, we need to record the run times and the cross-sectional area. The cross-sectional area in this case is just the area of the 3x5 card. You calculate the area by multiplying the length of the card times the width of the card. So in this case, the area is 3 times 5, or 15 square inches. So let's run this car down the track a few times and record the run times. Ready? Go! Next, we'll cut about 1 inch off the card so that it's only 4 inches wide, record its new area, and run it down the track a few times. Ready? Go. We'll just keep cutting off pieces of this card and running it down the track. All right, now that there's almost nothing left of this card, let's take a look at the results on a line plot. This time, we'll put the area of the card along the bottom and the run times along the side. For the first few runs, the area was 15 square inches, and we saw some of the slowest runs yet, almost 3 seconds. But as we reduced the area of the car got faster and faster. We can draw a straight line through the points just like we did in the weight plot and find that each additional 10 square inches of cross-sectional area adds 0.2 seconds to the runtime. But remember, we care about as little as 2 milliseconds. This means that we need to worry about any design feature that adds about 1/10 of a square inch to the car's area. The body of a Pinewood Derby car is 1 3/4 inches wide, so it's worthwhile to do anything that removes 0.06 inches from the height of the car. Guys, that's not very much at all. We really need to work at keeping our cars as low as possible.